welcome to our video. We are presenting about Wurtzite structure. So, I am Atila and this is Rohaya. So, do you guys wonder what is Wurtzite? Wurtzite is a brownish black mineral zinc sulfide that consists of zinc sulfide in hemimorphic hexagonal crystal or a fibrous state, and that is polymorphous with sphalerite.
So, have you ever learned about crystal structure, or you have any basic idea about the atomic arrangement?
Yes or no?
Wurtzite is one of the structure derived from the hexagonal closed pack HCP. Okay, let me explain. The Wurtzite structure takes its name from another polymorph of zinc sulfide. It differs from the saccharide structure in being derived from an expanded HCP anion array rather than a CCP array. But as in saccharide, the cation occupies half the tetrahedral holes. Okay, now I want to share with you guys an interesting fact about ice. Everyone knows what ice it is, but the real question is what type of crystal structure that the ice have. You might be wondering, right? Ice is having Wurtzite structure. The ice you all know is technically known as the ice or hexagonal ice. The underlying crystal structure of the oxygen atom in the crystal is known as Wurtzite, which is the general name given to this particular type of hexagonal crystal. So, the H2O has the HCP, which is all the 8 atoms at the corners, and it occupies the tetrahedral side. Wurtzite structure is very open. That's why ice have lower density than water. Other than ice, there are also another example of Wurtzite crystal structure, which are silicon carbide, beryllium oxide, and also aluminium nitride. Next is the unit cell for zinc 2+. There are 8 atoms at the corners of the HCP and 1 center, giving the answer of 2 unit cell. As 2-, there are 4 atoms at the edges and 1 atom at the center, give the answer of 2. So this is the overall calculation for the unit cell. For the zinc 2+, the unit cell is 2. For the sulfur 2-, the unit cell is also 2, giving the overall unit cell is 2. Okay, first, the location of zinc 2+. So there will be 8 atoms at each corner in HCP lattice, where the 4 atom is at the top and another 4 is at the bottom. It also has 1 atom at the center, which located at the half coordinate. Next is the location of sulfur 2-. So we already know in HCP there will be 10 of the tetrahedral side, but in this sulfur will occupy only half, so there will be 5. The location of atom will occupy at the 3-8 and also 7-8. Okay, the most important thing that you need to remember about Wurtzite is it having the hexagonal closed pack lattice, and it also will occupy half of the tetrahedral side. This is the plane view for the Wurtzite structure. Plane view is the projection representation from the above of the structure.
The coordination number for Wurtzite zinc sulfide is 4. Its empirical formula is ZnS. Each Zn2+ ion is surrounded tetrahedrally by 4 S2- ions, and each S2- ion is surrounded tetrahedrally by 4 Zn2+ ions. Thus, the structure has 4-4 coordination. Applications of Wurtzite is divided into 2 types, which are in biomedical and in optoelectronic. In biomedical, Wurtzite acts as the active site where biological events occur, subsequently defining the sensitivity and stability of the device. For example, biosensor. What is biosensor? Biosensor is a device that measures biological or chemical reactions by generating signals proportional to the concentration of an analyte in the reaction. Next is optoelectronic. Due to the similar size of host cation zinc 2+ and a transition metal ZNS zinc sulfide based on DMS can be easily fabricated. Zinc sulfide semiconductor has been considered as the best host material when incorporated with transition metals such as V, Cr, Ni, and many more for obtaining room temperature ferromagnetism. For example, light emitting diode LED. What is light emitting diode? Light emitting diode is the quantum mechanical effects of light on electronic materials, especially semiconductors.